Have you ever imagined what the planet was like at the exact moment it was born? Before oceans, forests, and life, Earth was nothing but a chaos of fire and destruction. Today, you'll embark on a journey through time to witness the very beginning of it all. Discover the secrets of the first day of our planet, a story that shaped the world as we know it. If this fascinates you, don't forget to subscribe to the channel and hit the notification bell so you never miss an exploration of the mysteries of our universe. Like, share, and let's journey through the wonders of Earth's incredible past together. Imagine a newborn planet, lifeless, with no oceans, just a swirling chaos of lava, stardust, and cosmic explosions. How did this primordial chaos transform into the Earth we know today? In this video, you'll embark on an epic journey, traveling 4.5 billion years back in time to witness the first day of Earth. We'll uncover the mysteries of a world where every second was a battle for survival, a place that resembled a sci-fi nightmare more than the perfect home for life. Have you ever wondered how it all began? How cosmic dust and the fury of asteroids gave birth to the planet we now call home? Stay until the end and discover the secrets behind Earth's formation, the birth of the Moon, and how the universe's most extreme conditions planted the seeds of life. Get ready to dive into the past in a way that will forever change how you see the world around you. 4.5 billion years ago, the solar system was a chaotic place, filled with stardust, gas, and fragments of rock in constant collision. Newly born stars illuminated the void, while massive explosions shaped the future of the planets. Earth began as a simple collection of particles pulled together by gravity. Over time, these fragments grew, colliding violently and generating enough heat to melt metals and form a core. Imagine the impact of millions of asteroids crashing into a planet under construction, releasing energy equivalent to billions of atomic bombs. This phase, known as accretion, laid the foundation for Earth, transforming cosmic dust into a protoplanet. It was the beginning of a journey that would take billions of years to create the planet we now call home. On Earth's first day, the planet was a true inferno. A glowing sphere of magma in constant turmoil, where volcanoes spewed rivers of lava relentlessly. The surface, instead of solid ground, was an ocean of fire boiling beneath a suffocating, opaque sky filled with carbon dioxide, methane, and steam. Meteoroids bombarded the primitive crust without pause, shaping the terrain amid devastating explosions. The atmosphere was a dense, toxic shroud, incapable of sustaining any form of life as we know it. It was a brutal and inhospitable world, yet full of potential. Imagine the roar of volcanoes and the impact of asteroids echoing as the first sounds of a newborn planet. Earth seemed like a place where survival was impossible, but within this extreme chaos lay the elements that would give rise to life billions of years later. Earth's first day was defined by an unimaginable landscape of destruction and transformation. Picture a newborn planet, a scorching sphere of molten magma, where the surface never fully solidified, and rivers of lava flowed in every direction, fueled by gigantic volcanoes that tore through the horizon with relentless explosions. The sky wasn't blue but a stifling shroud of toxic gases, thick with carbon dioxide, methane, and sulfur, creating a dense, suffocating atmosphere. The heat was so intense that rain, attempting to fall, evaporated before it could reach the ground, forming columns of steam that fed eternal storms. Meanwhile, asteroids and comets, drawn by gravity, relentlessly bombarded the surface, carving craters and releasing energy equivalent to thousands of nuclear bombs with each impact. These collisions not only shaped Earth's crust but also delivered new chemical elements, such as water in the form of ice, which gradually became essential for the formation of oceans. At this stage, Earth appeared to be a hostile and uninhabitable world, but every explosion, every impact, and every active volcano was contributing to a larger process, the preparation of a planet that would one day sustain life. It was organized chaos, where destruction and creation walked hand in hand, marking the beginning of an epic journey of transformation that would shape our home. Among the most transformative events in Earth's history, none was as dramatic as the catastrophic collision that gave birth to the Moon. Around 4.5 billion years ago, the young Earth suffered a colossal impact with a celestial body the size of Mars, known as Theia. This event was so violent that it vaporized part of Earth's crust and ejected massive amounts of debris into space. These fragments formed a temporary ring around the planet, much like the rings of Saturn. Over time, gravity pulled these fragments together, shaping the Moon we know today. This collision not only altered Earth physically but also stabilized its axis, directly influencing tidal cycles and climate, conditions that would become essential for the emergence of life billions of years later. Without the Moon, Earth's motion would be erratic, with drastic changes in its tilt, making the planet a far more unstable and hostile environment. Imagine the chaos of this impact: oceans of magma boiling, pieces of the planet being hurled into space, as gravity began sculpting the Moon into our natural satellite. The birth of the Moon serves as a reminder that even in the midst of extreme chaos, crucial elements emerge to shape the future. Today, as we look at the Moon, we see a silent symbol of one of the most tumultuous and decisive moments in our planet's history. Over time, Earth began to transform from a scorching sphere of magma into a planet where life would one day be possible. This transformation started as the surface gradually cooled, forming the first solid crust amidst a landscape still marked by active volcanoes and occasional meteorite impacts. As temperatures dropped, the water vapor in the atmosphere, produced by intense volcanic activity and cosmic impacts, began to condense. This condensation triggered the first torrential rains, which fell continuously for thousands of years. Water droplets, once impossible due to extreme heat, now found a surface to accumulate, forming the first lakes and seas. Ice-rich asteroids played a fundamental role in this process, delivering additional water to Earth's surface during the intense bombardment of its early phase. These primitive oceans reflected the chaos of their origin: hot, acidic, and filled with dissolved minerals, a chemical broth that would later become the cradle of life. Meanwhile, the unstable crust began to fragment, giving rise to the first tectonic plates that would shape continents and landforms. Imagine the deafening sound of endless storms, thunder reverberating through a heavy sky, and steam rising from hot surfaces, creating a continuous cycle of evaporation and precipitation. This marked a crucial turning point in Earth's history, the transition from an infernal planet to one showing the first signs of stability, where water, the essential ingredient for life, finally began to shape the landscape. It was the beginning of a vital cycle that continues to this day, a reminder of how chaos gave way to the promise of a future full of possibilities. With the formation of the first oceans and the partial stabilization of the planet, Earth was ready for one of the most important steps in its history: the emergence of the essential elements for life. In the warm, mineral-rich waters, a true chemical laboratory began to take shape. Minerals brought by underwater volcanoes and deposited by asteroid impacts mixed in a chemical broth, where simple molecules started to combine into more complex compounds. The primitive atmosphere, filled with carbon dioxide, methane, and ammonia, interacted with energy from lightning, volcanic eruptions, and solar radiation, creating the perfect conditions for the formation of amino acids, the fundamental building blocks of life. Imagine the first chemical reactions occurring in small pools or in the depths of the ocean, heated by hydrothermal vents releasing heat and energy. Modern experiments, like the famous Miller-Urey test, replicate these conditions and demonstrate that from this chemical chaos, the first steps toward life were inevitable. At this moment, Earth became a place of unlimited potential, where each chemical reaction was a step closer to the emergence of living organisms. Although life was still billions of years away, the stage was set, the right ingredients were in place, ready to ignite the greatest transformation in the planet's history. The early Earth was far from hospitable, but it was a place of immense potential. The oceans that formed from millions of years of torrential rains were unlike anything we see today. They were hot, acidic, and brimming with dissolved minerals, creating a primordial soup ripe for chemical reactions. Submarine volcanoes, still active beneath the ocean's surface, continuously spewed minerals and gases into the water, contributing a rich array of elements to this ancient chemical cocktail. Simultaneously, asteroid impacts deposited new materials, some of which contained organic compounds and water, further enriching the planet's surface. In this dynamic and volatile environment, simple molecules began to collide, interact, and combine, forming more complex compounds. These reactions were not random, they were driven by the energy and conditions provided by the Earth's extreme environment. This included heat from the hydrothermal vents deep in the ocean, electrical energy from lightning strikes, and ultraviolet radiation from the sun piercing through the primitive atmosphere. Together, these forces created the perfect setting for the chemical reactions necessary to kickstart life. The atmosphere of early Earth played a crucial role in this process. It was a thick, heavy mix of carbon dioxide, methane, ammonia, and other gases, vastly different from the oxygen-rich air we breathe today. This mixture, although toxic to modern organisms, provided the ideal environment for the formation of organic molecules. Lightning strikes in this atmosphere were like nature's own experiments, breaking apart gas molecules and allowing them to recombine into amino acids, the basic building blocks of life. The Miller-Urey experiment, conducted in the 1950s, replicated these early conditions in a laboratory setting. By introducing gases like methane, ammonia, and water vapor into a closed system and applying electrical sparks to simulate lightning, scientists were able to produce amino acids, proving that the fundamental components of life could arise from non-living matter under the right conditions. This groundbreaking experiment confirmed what scientists had long suspected, that life could emerge from the chaos of Earth's early environment. One of the most fascinating aspects of early Earth's chemistry is the role played by hydrothermal vents. These underwater geysers, located at the ocean floor, released superheated water rich in minerals and chemicals into the surrounding seawater. These vents acted as natural reactors, providing both the energy and the ingredients needed for complex chemical reactions. Here, simple molecules like methane and hydrogen sulfide interacted with metals like iron and nickel, leading to the creation of more complex organic molecules. The vents also provided a stable environment, sheltered from the chaotic surface conditions like meteorite impacts and ultraviolet radiation. Around these vents, life could have found its first foothold. Modern studies of these environments have revealed rich ecosystems teeming with life, offering a glimpse into how early life may have originated and thrived. Imagine the Earth's early oceans as a massive cauldron of potential, where every drop of water contained countless opportunities for chemical reactions. Molecules were constantly colliding, breaking apart, and recombining in an endless dance of creation and destruction. Over millions of years, this process led to the formation of increasingly complex compounds, including lipids, nucleotides, and proteins, key components of living cells. In some shallow ponds or protected oceanic niches, these compounds likely accumulated and interacted, forming protocells, simple structures that resembled the earliest forms of life. These protocells were not alive in the way we understand today, but they possessed some of the characteristics of living organisms, such as the ability to grow and replicate under the right conditions. From these humble beginnings, the first true cells would eventually emerge, sparking the dawn of life on Earth. The emergence of life's building blocks was not an event that happened overnight. It was the result of billions of years of trial and error, driven by the relentless forces of nature. The Earth's unique conditions, a molten core providing heat, a thick atmosphere trapping gases, and an abundance of water, created a perfect storm for chemical evolution. Each reaction, no matter how small, brought the planet one step closer to the emergence of living organisms. It's also important to recognize the sheer scale of this process. Early Earth was a planet in constant flux, with continents shifting, oceans forming and evaporating, and meteorites bombarding the surface. Amid this chaos, the ingredients for life assembled piece by piece, showing that even in the most extreme conditions, complexity and order can emerge. A glimpse into the future. Although life as we know it was still billions of years away, the stage was set for the greatest transformation in Earth's history. The building blocks of life had formed, the laboratory of early Earth was operating at full capacity, and the planet was ready to take its next step. From these small beginnings, a remarkable journey would unfold, eventually leading to the emergence of microbes, plants, animals, and, much later, humans. As we reflect on these events, we're reminded of the resilience and adaptability of life. The origins of life on Earth are a testament to the incredible power of nature to turn chaos into order, to transform destruction into creation. It's a reminder that the potential for life exists even in the harshest environments, a concept that fuels our search for life beyond Earth. The formation of life's essential elements was a pivotal chapter in Earth's history. It transformed the planet from a lifeless sphere into a place brimming with potential. Today, as we study the origins of life, we gain not only a deeper understanding of our past but also a greater appreciation for the intricate and fragile web of life that surrounds us. This knowledge inspires us to cherish our planet and continue the quest to uncover the secrets of our cosmic origins. Now that you know about Earth's first day, how about continuing this journey through the universe? Subscribe to the channel and share this video with anyone who loves exploring the mysteries of the cosmos. There's so much more to discover.